This lesson is on the key features of scatter plots and association. Scatter plots are graphs that use points to display numerical data. And of course, that word numerical means that it has to do with numbers. And that numerical data has two variables, or bivariate. We call this bivariate data. That's prefix bi, meaning two, because we have two variables. Scatterplots can help determine if one variable has an effect on the other, or if there are overall trends, patterns, or association between the variables. So association is the relationship that exists between the two variables that we're looking at. Let's look at this example of a scatterplot. Zara surveyed shoppers at a mall to see how many items they'd purchased and the total amount of money they'd spent at the mall. She used the data to create the scatterplot shown. How many shoppers did Zara survey? So in order to decide how many shoppers she had surveyed, we're going to have to count the number of data points she has. So she had 16 data points. So there were 16 shoppers surveyed. Now, if I look at that, I've got the number of items on my x-axis and the total spent on my y-axis. This is because the number of items spent is the independent variable because that's the one that's going to determine, hopefully, or maybe, the total amount of money spent. So does the number of items purchased seem to have an effect on the amount of money a shopper spent? So is there a pattern between what X does and what Y does? In this case, the answer is yes, because as X increases or goes up, Y also tends to increase. So as the number of items purchased increases, so does the amount spent. There are different types of associations, or another word for that is correlation. There are three different things that we can use, generally speaking, to describe whether or not the variables in the data set have a connection. If one variable increases as the other variable increases, we have a positive association or positive correlation. The variables change in the same direction. So if X goes up and Y also goes up, that is a positive association. A negative association happens as one variable increases, the other variable decreases, or they change in opposite directions. So you can see here, as X increases, Y is actually decreasing or going down. This is a negative association. You can also think about this in terms of slope. So if I drew a line through the middle of this data, that line would have a positive slope. If I drew a line through the middle of this data, that line would have a negative slope. All right, when no association is present, it means that the change in one variable has no effect on the change of the second variable. So in this one, you can tell that the data points are kind of all over the place. There's no real connection between what's happening to X and what's happening to Y. As X increases, sometimes Y goes up, sometimes it goes down. There's no general pattern. Now let's look at some examples of real-world associations. So the number of shoes a person owns and the number of states they've visited. So we have to think if the number of shoes I own affects how many states I've traveled to. Those don't really have anything to do with each other. So there is no association. I could be a backpacker and only have the pair of shoes that I'm wearing and have been all over the country, right? Or I could have 15 pairs of shoes in my closet and never have left my home state. So those don't have anything to do with each other. The size in ounces of a steak and the cost of the steak. So let's think about this. The cost and the size. As the cost increases, as the size increases, that cost is going to go up too, right? So that's a positive association. Obviously, the bigger the steak is, the more it's going to cost you to purchase it. Number 3 says the number of days since watering a plant and the moisture level of the soil. So if I'm looking at the days and the moisture in the soil, on the first day that I watered the plants, there's going to be a lot of water in that soil, right? But as the days go on and we have things like the plant absorbing the water and evaporation, that amount of water in the soil is going to go down. So this is a negative association. Or a negative correlation. Now we're going to look at some more specific ways to describe associations. So we can also describe the strength of an association and whether it's linear or nonlinear. Looking at the strength of an association, if the data points are close together or tightly packed, the association is strong. And if the data points are widely spread, but there is still a pattern, the association is considered weak. So if I look at this first association, those data points are all pretty close together. If I drew a line through the middle of them, the data points would all be pretty close to the line, right? So that's a strong association. The next one, if I were to draw a line through it, those points are a little bit more spread out from the line, right? So that's a weaker association. And you might find that sometimes the word moderate is really the best way to describe it. And moderate would be somewhere between strong and weak. Now, looking at linear and nonlinear associations, if you can draw a straight line to show the overall trend, the association is linear. If you cannot draw a straight line to describe or show the overall trend, it would be nonlinear. So in this first scatter plot here, I can draw a straight line and that would describe the general trend, right? That as X goes up, Y goes up. So this is linear. But if I look at the second one, if I were to draw a line through the middle of those points, it would be a curved line. This is actually called a parabola. But it's not a straight line, so it's nonlinear. So let's look at some example problems where we're asked to interpret some scatter plots. So the first question is, which scatter plots show linear association? Well, if I look at A, if I draw that line, that's not a straight line. So that's non-linear. If I look at B, that's a pretty straight line trend. So B is linear. If I look at C, it's also a pretty straight line trend, right? So B and C are linear. Number 5 asks for which scatter plots show nonlinear associations. So A and D both had curved lines through the center of the data points, right? So if the lines are curved, they're nonlinear. The next question is asking about the strength of the correlation or of the association. So number 6 asks which scatter plot shows the weakest association. If I look at A, those are pretty tightly packed around the line. If I look at B, that one's a little, I would consider that moderate, right? Not as strong as A, not as tightly packed as A. If I look at C, those are pretty spread out. Let's look at D to see if it's any different. D is also relatively strong, right? Or maybe moderately packed around that line. So C is the weakest association because those points are really spread out. If I look at A, that blue shaded area of how tightly the line or the points are packed around the line is a lot smaller, right? Now 7 says which scatter plot shows the strongest association. Well, if I look at B, that's more tightly packed than C, right? But it's looser than A. And if I look at D, that also is more tightly packed than C, but not quite as tight around the line as A. So A shows the strongest association. Now we're going to look at some scatter plots and do a little bit of matching. So if I look at the scatter plot in number 8, I cannot draw a line through that data that explains the trend. As X goes up, sometimes Y goes up, but sometimes it also goes down, right? So that's no association. And if it has no association, it can't be linear or nonlinear. So let's think about which of these descriptions on the right would be a correlation with no association. Our options are the temperature outside and the total gallons of gas sold at a gas station, the altitude of a hiker and the total oxygen level in the air, and the size of a home and the cost of the monthly utilities for the home. Well, I know that as altitude increases, there's less oxygen in the air. So as you get higher up in the atmosphere, the level of oxygen goes down, right? So that has an association. If I'm looking at the size of a house and the cost of the utilities, well, if it's a bigger house, it's going to have more lights. It's going to cost more to heat it because it's probably going to have more rooms, right? So that also has an association. But people are generally going to spend the same amount of money on gas in the summer as they do in the winter. So even if it's hot outside, you're still going to have to drive the same distance to work as when it's cold outside, right? So that is not going to necessarily have an effect on the amount of gas that's sold at the gas stations. Looking at scatter plot number 9, if I draw a line through that data, I can draw a straight line to describe it, so I know it's going to be linear. And as X increases, Y also increases. So as I move to the right, I'm also moving up. So I know that that's going to be positive. So this is going to be positive and linear. So I'm looking for a description where the independent variable and the dependent variable are both going to increase. I'm going to be looking at the last two descriptions, the altitude of a hiker and the total oxygen level in the air. Well, I know that as altitude goes up, oxygen actually goes down. So that's not a positive association. But the size of a home and the cost of the utilities are going to be a positive association because as the size goes up, so will the cost. And lastly, looking at that last scatter plot in number 10, I can draw a straight line through the data. So I know it's going to be linear, but that goes down. Those Y values go down as the X values go up. So that's going to be a negative linear association. And I know that the altitude, as the altitude increases, oxygen decreases. That air gets a little thinner, right? So that's a negative linear association.